Hello and welcome to Decoding the Cosmos, the channel where we unravel the mysteries of the universe. Today we're venturing into the unknown, diving deep into the top 10 theories about the Great Filter. This concept, shrouded in mystery and controversy, has sparked global debates and intrigued scientists for decades. If you've ever looked up at the stars and wondered about our place in the cosmos or pondered the silence of the universe despite its vastness, you are in the right place. We're about to explore the theories that might explain why we seem to be alone in this immense universe. So get comfortable, open your mind, and prepare for a journey through space and time. You won't want to miss this. Let's dive in. Have you ever wondered if we are alone in the universe? A question that has intrigued us for centuries, sparking debates, theories, and a relentless quest for answers. Across the vast expanse of space, with billions of galaxies each home to billions of stars, it seems almost inconceivable that we could be the only intelligent life in the universe. But if that's the case, why haven't we found any signs of them? This conundrum is what's known as the Fermi paradox. Named after the physicist Enrico Fermi, it highlights the apparent contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. Here is where the concept of the Great Filter comes into play. It's a hypothesis that attempts to answer this paradox. The Great Filter suggests that there is a barrier or series of barriers that prevent civilizations from colonizing the universe. It's like a cosmic speed bump, a hurdle so challenging that it stops civilizations in their tracks, preventing them from reaching a level of advancement that would make them noticeable to us. The term Great Filter itself paints a vivid picture. Imagine a colossal, invisible mesh stretched across the universe, filtering out civilizations as they attempt to progress. Some may never reach it, while others might hit it and collapse, unable to overcome the challenge. The Great Filter could be in our past, a hurdle we've already overcome, like the leap from non-living matter to living organisms. Or it could be in our future, an obstacle we've yet to encounter, like mastering interstellar travel or surviving a self-engineered apocalypse. So, if the Great Filter is real and it lies ahead, it would mean we are yet to face our greatest challenge. If it's behind us, then we may be one of the lucky few who have passed through it, making us a rare, if not unique, species in the universe. Intriguing, isn't it? So buckle up as we take a deep dive into the captivating world of the Great Filter and its theories. Let's explore the fascinating world of the Great Filter and its theories. First up, the self-destruction theory. This theory suggests that civilizations may, unfortunately, be their own worst enemy. Picture this: a society advancing at such a rapid pace that it fails to grasp the repercussions of its own technological might. The potential for self-destruction is a very real aspect of the Great Filter. Now, how could a civilization possibly bring about its own demise? Well, there are a couple of ways that this could happen. The most obvious, perhaps, is through nuclear warfare. The development of nuclear technology presents a double-edged sword. On one hand, it offers the potential for unlimited energy. On the other, it carries the devastating potential for global annihilation. A single misstep, a moment of recklessness or misunderstanding, could plunge a world into nuclear winter. Then, there's environmental collapse. As a civilization grows and expands, so too does its consumption of natural resources. Without sustainable practices, this could lead to widespread ecological devastation. Deforestation, pollution, climate change, these are all potential outcomes of unchecked growth. But what's truly terrifying about the self-destruction theory is that it's not some far-off abstract concept. It's a filter that we, as a civilization, could be facing right now. So the question is, could we be on the brink of self-destruction, or have we already passed this filter? It's a chilling thought, isn't it? But don't fret, we're just getting started. There are plenty more theories to explore. Next, let's consider the resource exhaustion theory. This theory suggests that civilizations may deplete their home planet's resources before they ever get the chance to reach other stars. It's a concept that may feel somewhat familiar, as it mirrors the environmental concerns we currently face on Earth. Imagine a civilization that continues to consume resources at an ever-increasing rate. As the population grows and technology advances, the demands on their planet's resources intensify. Eventually, they might use up all of their resources, water, minerals, energy sources, everything that's needed to sustain life and fuel progress. This depletion wouldn't just impact the civilization's ability to survive on their home planet. It could also prevent them from ever achieving interstellar travel. After all, building spaceships and fueling intergalactic journeys requires vast amounts of resources. If a civilization exhausts their resources before reaching this point, they could be forever bound to their home planet, unable to explore the cosmos or make contact with other civilizations. The resource exhaustion theory provides a sobering reminder of the need for sustainable growth. It suggests that our future, and the future of any other intelligent life in the universe, may hinge on our ability to balance progress with preservation. We must learn to use our resources wisely, ensuring that we can sustain our civilization and reach for the stars without destroying our home in the process. Will we run out of resources before we can reach the stars? Only time will tell. What about the cosmic catastrophe theory? This is where the plot thickens and our story takes a more celestial approach. As we gaze upon the vastness of the cosmos, we are reminded of its infinite mysteries and potential hazards. One of these dangers is the possibility of a cosmic catastrophe, a supernova or gamma-ray burst that could wipe out civilizations before they have the chance to reach out to others. Imagine a supernova, a star exploding with a force so great that it outshines an entire galaxy, even if just for a brief moment. The energy and radiation from such an event are capable of obliterating life on a nearby planet. Now consider a gamma-ray burst, the most powerful explosion known in the universe. These bursts release more energy in a few seconds than our sun will over its entire 10 billion year lifespan. A close encounter with either of these cosmic phenomena could spell the end for any burgeoning civilization. But where does this leave us, here on Earth? Well, our planet has been around for over 4.5 billion years, and in that time, we've been fortunate enough to dodge these cosmic bullets. Yet, the universe is vast and unpredictable, filled with dangers we are only just beginning to understand. So, we return to our original question: could a cosmic catastrophe be waiting to wipe us out? As we continue to explore the cosmos, we must be prepared for the possibilities, however terrifying they may be. Let's delve into the biological limitations theory. Now imagine the vast complexities of life as we know it. The intricate dance of molecules that gives rise to consciousness. The delicate balance of systems that allows for life to persist. It's all pretty impressive, isn't it? But what if these very complexities, these marvels of evolution, are the very shackles that prevent us from reaching out to the cosmos? This is exactly what the biological limitations theory proposes. It suggests that there might be inherent biological factors that limit the ability of civilizations to communicate with others or even survive long enough to make the attempt. Think about it. Our lifespan, compared to the age of the universe, is but a fleeting moment. We're here today, gone tomorrow, in cosmic terms. And then there's the matter of cognitive abilities. Our brains, as amazing as they are, have limitations. We can't comprehend certain mathematical concepts without the aid of computers. We struggle with the vastness of time and space, and our understanding of the universe is, at best, incomplete. In essence, the biological limitations theory argues that our biological makeup might be the invisible barrier, the great filter, preventing us from truly becoming a spacefaring civilization. It's an intriguing thought, isn't it? That the very thing that allows us to contemplate the cosmos might be what's stopping us from exploring it. Are we biologically limited in our quest for the stars? Next, we tackle the rare Earth theory. Picture this. In the vast, infinite expanse of the cosmos, the Earth is a solitary gem, a rare jewel where the conditions for intelligent life have aligned perfectly. This is the crux of the rare Earth theory. The theory proposes that planets capable of supporting intelligent life like our own might be extremely rare. It's not just about finding a planet in the habitable zone of a star where the conditions might be just right for liquid water. No, it's far more complex than that. Consider Earth's unique characteristics: a magnetic field protecting us from harmful solar radiation, a moon to stabilize our planetary tilt, plate tectonics recycling carbon to prevent a runaway greenhouse effect, and the list goes on. These factors, and many more, contribute to making Earth a suitable cradle for life. But what if such a perfect alignment of conditions is a rarity in the universe? What if most planets, even those in habitable zones, lack one or more of these crucial elements? This could significantly reduce the number of planets where intelligent life could evolve, explaining our apparent solitude in the cosmos. So the rare earth theory, while not discounting the possibility of life elsewhere, suggests that the emergence of intelligent life might be an extraordinary exception rather than a common occurrence. Is Earth a rare gem in the vast universe? Perhaps we are more alone than we think. Let's examine the predation theory. This theory posits a chilling perspective on the cosmos, suggesting that advanced civilizations might be predatory in nature. The universe is a vast and ancient place, and it's plausible to think that some civilizations have evolved far beyond our current level of technology and understanding. Imagine a civilization that has mastered interstellar travel, harnessed the energy of stars, and can manipulate matter at will. Such a civilization would be incredibly powerful, but with great power comes great potential for danger. What if these advanced civilizations view younger, less developed civilizations not with benevolence but with hostility? The predation theory suggests that these advanced civilizations might destroy other civilizations before they become a threat. It's a chilling concept, the idea that there could be cosmic predators out there, waiting for us to reveal ourselves. In this scenario, our broadcasts into space, our attempts to reach out to the cosmos, are not just messages of peace and curiosity, but may also be seen as acts of provocation or even aggression. In the grand cosmic game of survival of the fittest, these predatory civilizations could be the top of the food chain. And if we're not careful, we might just end up as their next meal. It's a sobering thought and a stark reminder of the potential dangers that could be lurking in the vast expanse of the cosmos. Could there be cosmic predators waiting for us to reveal ourselves? Next up, the simulation theory. This fascinating hypothesis suggests that everything we consider reality might be nothing more than a sophisticated simulation designed by a higher intelligence. Imagine for a moment that every star in the sky, every blade of grass under your feet, and even your own thoughts are all part of an intricate virtual reality. The idea isn't as far-fetched as it might sound. Think about the rapid advancements in technology we've seen in just the last 100 years. Now consider a civilization that's thousands or even millions of years more advanced than us. It's conceivable they could create a simulation of such complexity that the inhabitants would perceive it as reality. But what does this have to do with the Great Filter and the Fermi paradox? Well, if we are living in a simulation, it might explain why we haven't found other intelligent life out there. Perhaps the architects of our reality didn't program any other civilizations into our virtual universe. Or they might have designed the simulation specifically to observe how we react to the apparent solitude. The simulation theory opens up a Pandora's box of philosophical questions. If our reality is a construct, what does that mean for our understanding of existence? Could there be multiple simulations, each with their own version of life and civilization? The possibilities are as endless as they are mind-boggling. Are we living in a cosmic simulation? It's a question that challenges the very nature of our existence and our place in the universe. Let's explore the Transcension Hypothesis. Imagine a civilization so advanced that it has moved beyond our current understanding of space and time. This, in essence, is the Transcension Hypothesis. It proposes that sufficiently advanced civilizations may eventually transcend our reality, becoming virtually undetectable to us. Under this hypothesis, we're not merely considering advanced beings who have mastered interstellar travel or harnessed the power of stars. We're talking about entities that have evolved beyond the physical constraints of our three-dimensional universe, perhaps venturing into extra dimensions or creating their own pocket universes. Transcension could be the ultimate destiny of all sufficiently advanced civilizations. It's a leap into a realm beyond our current comprehension, where traditional notions of space and time no longer apply. Think of it like a caterpillar metamorphosing into a butterfly. The caterpillar's world is confined to the ground, while the butterfly can explore the skies. Similarly, a transcended civilization would exist in a realm far removed from our own, beyond the reach of our telescopes and sensors. This hypothesis is both exciting and disconcerting. On one hand, it opens up a world of possibilities about the nature of existence. On the other, it suggests that we may never find evidence of advanced extraterrestrial life, simply because they've moved beyond what we're capable of detecting. So, in a universe teeming with potential life, we may forever remain like the caterpillar, oblivious to the butterflies flitting above us. Could advanced civilizations be transcending our reality? So, are we alone in the universe? That question has been the bedrock of our exploration today, as we delved into the top 10 theories about the Great Filter. Each theory, a unique perspective on the potential barriers to the emergence of intelligent life in the cosmos. We started off with the self-destruction theory, a chilling reminder of the dangers of our own hubris, where nuclear war or environmental collapse could be the end of intelligent species. Then we pondered the resource exhaustion theory, which suggests that civilizations might deplete their planet's resources before they can reach the stars. The cosmic catastrophe theory offered a different perspective, suggesting that unknown dangers lurking in the deep space could be responsible for wiping out intelligent life. The biological limitations theory, on the other hand, proposed that the evolution of intelligent life itself could be an extraordinarily rare event. We also explored the rare Earth theory, which argues that the conditions necessary for life might be so specific and rare that it's a miracle we exist at all. The predation theory presented a darker view, suggesting that advanced civilizations might have a predatory nature, extinguishing other life forms before they can flourish. The simulation theory took us on a philosophical detour, positing that we could be living in a simulated reality, and the Transcension Hypothesis proposed that civilizations might leave our perceivable universe entirely, evolving into a higher state of existence. Each theory is a piece of the puzzle, a potential answer to the Fermi paradox and a reflection of our own existential musings. The implications of the Great Filter are profound. If we've already passed it, we could be one of the lucky few civilizations in the cosmos. But if it's still ahead of us, our future might be fraught with challenges we can't yet comprehend. Whether we are alone or not, the Great Filter gives us much to ponder about our place in the universe. Before we end this cosmic journey, we hope you've enjoyed this exploration into the Great Filter and its implications. If you've learned something new today, or even if this video has simply sparked your curiosity about our place in the cosmos, we encourage you to hit that like button. Your support helps us create more content like this. We'd also love to hear your thoughts on these theories. Which one resonates with you the most? Do you have your own theory about the Great Filter? Share your thoughts in the comment section below. We're all explorers here, and your insights might give us a fresh perspective. Don't forget to subscribe and hit the bell icon to stay updated on our future journeys into the mysteries of the universe. And if you found this video thought-provoking, why not share it with your friends and family? Let's spark a conversation about our place in the cosmos. Remember, the universe is vast and filled with mysteries, and each one of us has a role to play in decoding it. So until next time, keep exploring, keep wondering, and keep decoding the cosmos.